Okay, that was quick. Excellent. Yes, I'm very happy to be here. Lydia yesterday at the dinner asked me what I thought when I got the invitation to speak here. Oh, I'm hearing myself. And the answer is I'm quite happy to do these things and to speak to people kind of outside of the research community about these large language models, because I feel a bit of a responsibility. They are the product of exactly my research field, and there's a lot of justified confusion out there. So it is good to get into a conversation with people who might be like you, who might be shaping how these things are actually going to be used, if at all. So I have 10 minutes, so this is going to be very high level, obviously. And what I thought I'd do is, in the first part, I talk a bit about the history, about how we got here. And so in the field, we had a little bit of a heads up. We've been seeing this coming for a couple of years, but not a lot. So a lot of it was surprising for us as well. And in the second part, I will talk a bit about our sort of current understanding of LLMs and maybe a positive path forward from it. Okay, so here are the past 3.5 decades. The history of the field is longer, but this happens to be the time that I was involved in this field, first as a student and then as a researcher in various capacities. And what's interesting about this is that I have witnessed already 2 paradigm shifts, 2 very different ways of doing things, which brought us here. So in the 1990s, this was very much about symbolic methods and knowledge representation. So what we would do is to process language with computers, we would go to our linguist friends, get grammars from them, and then write programs that process these grammars, right? And these are programs that are very much recognizable to you as well, because they are fully thought through these programs, hopefully at least, ideally at least. I did, around that time, the late 1990s, I did train my first neural network. I took a class on neural networks at the University of Bonn, where I studied computer science at the time. And I also trained my first language model in the late 1990s, I think, at an exchange semester in Edinburgh. So these are not new techniques, right? These are fairly old techniques, but they were very niche at the time. They had a very specialized use. I would love to be able to tell you that I stuck with these methods like the fathers of deep learning and reaped the benefit 20 years later, but I did not. I worked with the mainstream methods of the field, which were symbolic methods at first. And during the 2000s, we started to use statistical methods or machine learning methods that basically learn parts of the module, of the processing module. But the point is that there was still symbolic knowledge representations. The way that you got these representations, it helped you to process language, to understand language, was machine learned, but the representations themselves were designed by humans to be clever. I myself got an induction in the latest paradigm in 2014 when I did a sabbatical at Microsoft Research in Seattle. And that was crazy. There was really a buzz in the air, and people were super stoked by the first neural methods that started to work. And at that time, that was word embeddings. So there's a particular way of representing the semantics, the meaning of words. But what was new about it was that the representations weren't designed. The representations were machine learned as well. The machine basically came up with the best representation that was best for the task, for a very simple task, but it turned out to be very general. And that kind of set the mood, set the scene for where we are now. So the first ingredient that changed many things was representation learning, that the representations are built by the machine itself. And then with that comes end-to-end systems. So instead of building modular computer systems, what you do is you really train for the task and let the machine do all the intermediate steps itself. And then in 2018, the BERT paper came out. Just to get an idea of how many people know something about this. Does anyone know this paper? Yeah, a good few people know this paper. Okay, so this was the first paper that really showed that transformers would work. So this was the transformers paper was before that, but this was the first paper that applied it and got fantastic results. I was at a conference. This paper came out in 2018, late 2018. I was at a conference a couple of weeks later, and people were kind of stunned. People were giving their presentations as they planned. We were showing their results, and then they said, okay, when we wrote this paper, these were the state-of-the-art results. We tried this new BERT model, and we got this BERT model is 10% better. It blows our model out of the water. So that was a moment there. And by that time, then the race was on to develop, to do something with this. For various reasons, as we all know, OpenAI was the team that produced the first model that, or product maybe, that caught people's attention outside of the field. Many other people tried as well. It's a little bit of a puzzle why Google didn't get there. But anyway, so that's where we are now. And as on the left-hand side, I subsume this as generalist models. So the really new thing is now that we have models that aren't even trained for one particular task. Well, they are trained for one particular task, namely next word prediction. But it turns out that this is super powerful, that you can turn them into generalist models. Okay. And this really is a new situation. So there has been a paradigm shift, and there has been kind of, okay, what do we do now? Where do we go now with this field? And finally, how can we build applications with this? How can we make this useful for people? Okay, so this is my part one. I'm not really sure what the moral is of this, because unfortunately, these methods are a little bit stupid. It is a little bit insulting, actually, that these very simple methods, when scaled up enormously, work that well. But that's where we are, and now we need to do something with this situation. Okay, so in my research group, we work on language use a lot. We think about the pragmatics of language, about kind of the subtle cues that change the meaning and contextualize the meaning. And we have a lot of projects now trying to understand to what degree LLMs can model this. I want to give a shout out to one project we're doing. We have a benchmarking tool for LLMs that tests pragmatic abilities by letting them play dialogue, conversational games kind of against themselves. But that's not what I want to talk about in the remaining whatever many minutes. We are also doing thinking about the role of LLMs that they can and cannot play in technology. And these are two papers that I want to very briefly touch on the remaining slides. Okay, so here are three observations that we maybe can discuss later and do something with. The first one is that LLMs have decoupled fluency from expertise. And I guess you guys all know this. But it is surprising how many people sort of in the general population still have not fully understood this, right? Because it used to be the case that if someone produces flawless text on a subject, it used to be the case that there are also experts in the subject matter, right? But this is very much decoupled for technical reasons, right? The training objective of these models rewards them for producing the right words and the right phrases, but it has no access to the underlying causes for why you would want to produce particular words, right? So it gets the tone very right of almost anything you ask it to do, right? But there are no guarantees on whether it will get the content right. And that is a bit of a problem, perhaps. Okay, second point, computers cannot assert, even if the accuracy were a lot higher and hallucinations were very rare, they're still fundamentally different from human speakers because they don't care. There's no one there who could care about what is said, right? And my conclusion, at least from this, is that humans need to retain semantic control over the output. Basically, you need to be able to undersign whatever you're producing with LLMs. And that restricts the use cases quite a bit, I think. But I think that's non-negotiable with these technologies. And the third point is that understanding LLMs as language controllable function approximators yields an understanding with which we can do something. So the idea here is that instead of you writing the code for a function, you search for this function in the LLM, the latent space of the LLM, and then you treat the LLM indeed as having implemented this function. But it's only approximating this function, right? And that interesting challenges come from this. Okay, I'm already over time. I'm going to skip over a lot, but I want to end a little bit on what I think is a positive way forward for using AI technologies. And maybe we can discuss this in the panel. Okay, so in a positive future, what has happened is that users and buyers of this technology have developed a good mental model of this technology, right? And have avoided all the anthropomorphization that is out there. So these things are not interns, they're not co-workers, they're not friends, they're programs, right? They're programs that have to work and can be evaluated as such. And if they don't work, you don't use them or you fix them, right? And the onus here is, I guess, on us as educators, really driving home this message to people that this is what these things are. De-skilling has been avoided, right? So there is a danger when you sort of naively build these techniques into products that you are de-skilling people because they rely on these products too much and forget how to do the task themselves. And to avoid this, some of this is on you. I think you can, when you implement these systems, you can make engineering and design decisions that avoid this. Some of this is on us, it's on the research side. We need to do more research on interpretability, and some is on the regulation side. Okay, another point, responsibility offloading has been avoided. So the tools are designed in such a way that people actually accept the fact that they have to have semantic control. Again, there's a design component to this. Maybe you have to design friction into the tools, right? So before sending off the email that you had the LLM formulate for you, get some proof from the user that they've actually read what has been produced. Something like this. This might be a naive idea, but this is for you to think about. Okay, what else do I have? Cost externalization has been reverted. These things need to be as expensive as they are. We know this from many areas. This holds for traffic as well. This holds for manufacturing. This holds for these things as well. They have to have the real costs, which might drive some use cases out of being economically viable, but then so be it, right? And the last point maybe is something that interests you as well. Some form of cultural sustainability has to be achieved. So maybe we can come up with models where, so one part might be licensing training data and paying the creators of the data that these models were trained on that way. But there might be room for creative models, like where each instance where something is generated that was can very clearly be traced back to source material. The creator of the source material is paid in some way, right? This is unlike, obviously, real world. I mean, normally, if a teacher teaches you something, it's not the textbook author who gets money the author of the textbook that the teacher learned this from. But these are new things, so new models should be tried out. Okay, with this, I think we can go over to the panel discussion. Okay, thank you.
Thank you so much.
I'm gonna leave it on this. Yep, coming.
All right. So we are gonna have a bit of a discussion here, and then also have time for audience questions. And my first question for both of you is: a friend of mine a while ago said AI. Thank you, Victoria. AI is always that which we don't quite understand right now. And what was AI 10 years ago, we today maybe no longer consider AI. And I would love to hear from you. What do you consider to be AI today? And what do you maybe not consider to be AI? Anyone?
Why don't you start? Yeah.
I'll guess to go first.
Yeah. So I got the question list in advance, so I had time to think about this a little bit. I know a variant of this, and it's called the AI paradox, I guess. And that is kind of more about goalpost shifting, right? So there the complaint is that people's, as soon as it starts working, people say this is not real intelligence. And I think I have little problems with this because I don't think human value derives from intelligence only. So I don't feel threatened by programs doing tasks that appear intelligent. So in that sense, it doesn't quite work for me. And in a more technical sense, AI is a programming technique for me. So what has been programmed in this particular way stays that way. I'm on the contrary, I'm actually still blown away. I'm old enough to remember how terrible ASR was, and I'm still blown away by how good it works these days. So in that sense, there's still magic for me. Yeah, that's the reply, I guess.
All right. Maybe I introduce myself first because I don't think we've done that yet. And so maybe there are some who are online who don't know. I'm Eike. I've been a KDE developer for about 20 years on many of our applications and also on the Plasma user interface. So I think intelligent is a very complicated term. But when I go look for guidance, what it means to me, I end up thinking about what our mission is at KDE. And our mission is chiefly to develop end-user software. So what does intelligent mean to a user? What makes a user want to describe a computer system that they interact with as intelligent? And has that recently changed? And I think it has, because particularly large language models, I think, have given computer systems in a broad way that new ability to do what you mean rather than what you say, which is not what users are used to from a computer, outside of maybe some sort of pattern recognition, habit learning, and making suggestions like that. But now you can talk to your home and say, I want my room to look like the Barbie movie, and that turns the lights pink. And that's something that it just couldn't do before. And it does this in a very generalist fashion, so statistical inference. It doesn't necessarily model you, so it doesn't understand what your needs are individually. And that's where some of the sort of problems lurk. But I think it has raised the bar for what users expect computers to be able to do. And yeah, I think that is something that we definitely have to deal with. But also we have to, I think, communicate very clearly when we cannot actually match these expectations and where to draw the line.
That's a very good point. And I love your Barbie example. Which brings me to my next question. Where do you use AI in all its shapes and forms in your daily life right now? Do you turn your room Barbie pink?
I do on occasion. And I think, I mean, for me, and maybe I'm weird, but I love using these models to amuse myself. So I often generate a funny picture just for my own purposes, or to share with someone, or a funny humorous text, because it does it faster than I can do, but I can give it somewhat clear requirements. And I mean, you can play with the humor of it a lot. ChatGPT has such a peculiar writing style that is immediately recognizable to anyone at this point, and you can play around with them. I also, and this is interesting, right? So I do use it as an accelerator when I do development work, and it turns out to be most useful when I use it for an application that I'm already an expert in, because then I can give it very specific requirements, but I can also check whether it actually did what I wanted it to do. Like, I can tell if this code is bad or not. And the usefulness sort of tends to break down as soon as I venture into a space where I cannot verify whether what I got is actually useful or not. So I think that's an interesting observation too.
Yeah, I guess AI in your question means LLMs, right? Because I guess we all use AI in very many instances, like when we turn on the dishwasher, right? And I mean, this kind of goes back to your first question. There's still machine learning modules in there, but for LLMs, yeah, that's interesting. I mean, as I said, this comes out of my field, so I feel the responsibility to try this out a little bit, but I don't use it much for many, and maybe this is connected to the de-skilling. I've been in this job for a while now, and many of the things that I'm doing, I've been doing for a very long time. So I think I'm still a lot better at generating chunks of text than an LLM is, and it would slow me down if I had to correct the text that comes out of it. I have found one good use case for me, which is so I like coding, but I get it to do it a lot less often than you guys, I guess. So with a space of months in between. So when after a couple of months I get to look at code again in Emacs or whatever, I have forgotten the most embarrassing things, right? I've forgotten how to the syntax of a for loop in Python or something, and it's quite good for this. So I ask models to solve my problem. I look at the code. I remember what code looks like. I remember the syntax, and then I write it myself. I completely disregard the solutions. But as this kind of prompt, as memory aid, I guess it works quite well. But I'm more worried about what it does to people who are new at tasks rather than people who have been doing tasks for a very long time.
I think you're onto something there. I think it's useful as a sort of checks and balances sometimes, as a reference. As in, you write the code yourself, you also have it generated, you compare the two, you check whether you've possibly missed anything, or whether the alternate approach might be different. So I think that's interesting. I mean, the access to the broad range of data it was trained on for knowledge-based queries, it's sometimes quite interesting. I think I want to, if I can respond on the de-skilling parts. I used to be very worried about de-skilling. And probably I still should be, but I had an experience as well that made me a little bit less afraid of that. So in KDE, we have a mentor program. We have a website that lists a number of members of the community who you can contact on a one-on-one basis if you want to ask questions or you want some tutoring on how to do KDE development. And there was a young person who reached out to me, and they wanted to be a KDE contributor. They had some limited programming training, but really they were starting out with C++. And this being 2022, I guess, of course they were using ChatGPT already, because it's kind of hard to ignore if you are trying to climb a mountain like that. So we made the agreement that yes, he could use ChatGPT for this, but we would share an account and I would be able to read what he asks the AI so that I can steer him clear of going into a completely wrong direction. And it was pretty interesting to see him interact with the system. And of course, it was very hard for him to keep up the discipline to try and do things by himself. He would lean very heavily on code generation in the end, and it would become sort of a cycle of, well, this doesn't work, so I go back to the model immediately and I ask it to fix it up or make changes. And it falls apart pretty quickly there. You can ask it to generate something once, that sort of works, but integrating 100 interactions over time doesn't yield a useful program. And he started recognizing at some point that he would run into a type of walls that he just couldn't leap over anymore, because he didn't end up understanding the code file that he had produced in that patchwork fashion. And he came by himself to the conclusion that whenever I do it manually and I fight that 3-hour battle to produce one line of code, at the end of that, I actually understand what it does and why it is fashioned that way. And after about half a year, he was like, this is not mentally healthy for me. I will stop using this crutch. So I think I'm kind of an optimistic person. And I think also around this technology, society will come to a point where sort of the use it or lose it of it all is apparent. It's just like using stairs instead of an elevator occasionally, or things like that. And particularly with writing, I agree with you. I mean, I even turn off the word completion on my phone keyboard, which this is a sophisticated version of, right? Because or spell checking, because I've always felt like my orthography will just suffer if I don't learn how to spell myself. And I think a lot of people come to the same conclusion. So I'm not that worried about it. I think we'll learn how to keep it under control.
It's an empirical question, though, of course. I mean,
Yeah.
in a company, I guess you would want to measure whether this is an efficient way. Like
Yeah.
letting people run into walls and take half a year to do so, there might be more efficient ways of training them up.
But I mean, particularly if you're an employer, I think you should also learn to recognize the value of investing in your people. And I mean, obviously training is a thing, and the absence of using AI tools may constitute training that gives you longer lasting value out of a person if you end up shaping their intellect rather than turning them into a prompt engineer, for example. Yeah, I hope so, at least.
That brings us to some of the scenarios that the world is talking about, right? Anything from the worst the world's going to end to this is the magical thing that's going to solve all of our problems tomorrow. And let's start maybe a bit more with the positive side of that, or the more optimistic side of that. What gets you excited right now and hopeful about current AI developments?
Okay, I go first. I mean, for me, this is a fascinating, super exciting time. Obviously, there are things possible in my field that just weren't possible 5 years ago, and there's a huge open vista of things to explore. So that obviously is exciting. It's also on the sort of more applied side, it will also be super interesting to see how people turn this into actual products. And what I always say is this, these models, and again, this is difficult to understand if you don't know these models more closely. They are kind of doomed to be generalists, right? Because they are, after all, on some level of description, they are autocomplete on steroids, right? And so they will complete anything and everything you give them. You give them a prompt and they complete it in some way. And if that's not what you want in your application, because you only want to produce a summary or you only want to do something else, you have a hard task of designing out this generality again. But I think the way forward to actual products is to do exactly that. And that's what I try to get at with my metaphor of them being function approximators. So I think also on the applied side, there's a lot of super interesting work, especially in the user interface space. I don't think the free chatbot with a weird, quirky personality type interface is the final form of this technology. This is just the first thing that people came up with because it's just so natural. You can train this behavior in very easily. But to be really useful in sort of standard, normal, accepted ways where you measure the usefulness, other than, wow, this is a funny sounding limerick, or I'm impressed by how cute this sounds, or whatever. These are not good metrics for measuring actual utility in real contexts. So I think there's a lot to be done there, hopefully by some of you, some of it by some of you here. Yeah.
So I think what excites me about it comes down a little bit to how I sort of conceive of the role of what an engineer does in society, or what we do broadly do at KDE. So when I was a young boy, I used to go to the Berlin Natural History Museum a lot. I requested to go there every birthday that I had. And the Natural History Museum has a wonderful expo on sort of Stone Age civilization and how people used to live many thousands of years ago. And you get to see the tools that that society used, little, fashion stones to make fire and so on. And it occurred to me, even as a kid, that somebody had to think of making that stone and then produce it and give it to others. And then they might use it to make fire. And then they sit around that fire and, I don't know, start speaking, and boom, civilization. And I think that is sort of what I aspire to do in its modern incarnation, to build tools that allow other people to live their life a little bit better and sort of spread civilization and culture. And I think AI and large language models are such a heated topic because they promise to help us to make better tools. For example, allowing people to accomplish sophisticated tasks without specialized training, because they maybe bridge that natural language understanding gap, the kind of do what I mean instead of what I say part. But at the same time, they seem to sort of encroach on that humanity. So rather than help, they supplant. And I think that's where a lot of the emotion comes from. What I liked about your presentation and your approach at all is to sort of try to turn that heat level of emotion down a bit and pare it down to, what does it actually do? What is the mechanism here? What are the limitations of it? And I think for developers, it's very useful to think of it as sort of a pure function that accepts fuzzy parameters, and you can't always trust the return value. I think that's quite useful, but what that allows you to do is very powerful. I mean, what you can now accomplish as a developer, let's say building a speech system on a weekend, as opposed to taking 5 years at Amazon with 300 people, is pretty stunning. So that's exciting.
Now we talked a bit about the positive and hopeful side, but there's also a lot that gives people pause. What is that for you?
Right. Yeah, I mean, as I said, these are powerful tools, or at least they appear to be powerful tools. They are very confident themselves that they are powerful tools. And it gives people the temptation to build powerful applications and to shoot themselves very powerfully in the foot with them. And there's also a lot of money in the system, like a lot of money. I wanted to say that, I didn't get to say this, but a lot of these breakthroughs, I have to admit this, they're coming out of commercial labs, they're coming out of industry labs, not academic labs, just because of the insane capital expenditure that is needed to build these things. So there's a lot of venture capital in there, and at some point, some people want to see returns on it. So the temptation to build applications that are given more power than they should have, given the lack of guarantees, that is real, and that is the part where doom lies. It does not lie in ChatGPT becoming conscious and trying to kill us all because we ask such inane questions all the time. It's people building applications that have a degree of autonomy that is not warranted, and this, we know that complex systems are difficult, and this can go off the rails quickly. So that would be my worry.
Yeah, so I do think that around this technology we have obviously a big problem with what you could call media literacy. Right? As you pointed out, users need to have a good model of how these systems actually work, what their limitations are, where your responsibilities as a user lie, also perhaps whether it's actually good for you to use it or not. And a lot of the commercial vendors in this space are not incentivized, to be honest, about many of these things. Only to the extent that they're worried about liability will make them do it. I think for us, because we have a lot of freedom from those constraints, I mean, surely we also worry maybe about liability, but we get to worry about many more things. But I think KDE broadly is in our mission is to figure out what it means to make socially responsible software. And licensing for us is an important aspect of what socially responsible means. We have very strong ideas about that. And for example, we should also delve into what we think that means in the AI model space. But socially responsible also means sustainable, for example, or protecting privacy. And it can also mean giving users a realistic picture of how much AI is good for them, and transparency over whether it's used or enabled or not, and things like that. And I think that is what I expect of ourselves, that we should pay attention to this to avoid the doom, perhaps.
That brings us right back to KDE's role. And maybe one last question before we go to audience questions. So are there areas in KDE where you see positive potential for using generative AI in applications, in the development, in our community?
I'll go first. So yes, I mean, I have a laundry list of little like wish list items where I think even the current level of technology would enhance our applications. Maybe something that you would benefit from as an academic who has to read a lot of long PDFs. I would love our document viewer to be able to answer the question which page of that long PDF a particular topic is being talked about, rather than having to do a keyword search, which is very clumsy. So little things like that. But I think, again, it's not just the features, it's also the fact that we have an opportunity to do it differently from the other players. I mean, we have a goal, for example, to protect the user's privacy that makes us much more interested, I think, sort of in running these technologies locally rather than on a server, and the other players are not doing it that much. So I think there we can offer something substantially different to the user as well, that I think a lot of users want. And I'm hoping that we get to do that.
So maybe one short. So I think you have an opportunity, since you don't have commercial pressures so much or at all. You have an opportunity to also lead in what you're not doing. So I think a very lazy way of integrating AI or LLMs is to have a button that calls ChatGPT, right? And that obviously requires no thought at all, and does not address any of those problems that I try to highlight. So I think you have a way of doing things more clever than this. And as I said, my guess would be that trying to cut down on the generality and really investigating a use case and making sure that this one use case is actually implemented well, that's an opportunity, I think.
I agree with you. I think one of the interesting things about KDE's software and its technology stack is that we've always been very driven to create sort of libraries and frameworks that are used all across our applications, and that make them able to interact with each other to some degree, and you can query a lot of information about these applications as they're running. And I think there's a lot of opportunity there to find sort of these more surgical places where can you conceive of a semi-intelligent function that you could sort of lob in between it that would do something useful. That is not just bring up a text box and start typing, but that selects usefully among things it's exposed to, for example. And things like that. I hope that, and this is a really interesting developer problem. What would be a good API for developers to run AI jobs like that, and how can they do things together? That's very interesting.
All right, thank you so much. Then let's take some audience questions. Who has questions? All right, let's start with you.
Oh, is this working? Okay, so when it comes to large language models, this does not happen to all fields of the AI, but it does happen here. One of the most serious problems there is that it needs a lot of data, it needs a lot of computing power, and we as free software developers, we usually don't have the resources to purchase them. So, and also we probably won't want to use a service that is proprietary and hosted by others. And, although they might have some privacy policy, we might still not like it. We don't want to give our data to just some random third party. What do you think can solve this problem?
Yeah, this is a real problem. These models only are as good as they are because they have ingested a lot of data, and it's not a linear curve in the capabilities, right? You just need a lot of data. It's not that if you use half as much data, it's half as good. There is a certain amount of data you absolutely need to get the basic capabilities off the ground, and that puts the training from scratch of these models out of the hands for the foreseeable future, out of the hands of organizations without a lot of access to a lot of capital. Yeah, there's a problem. There are some organizations, for example, AI has just released a new version of the Olmo model. They are quite open about the data they're using. They've released all the checkpoints and so on. But there is, of course, Llama by Meta, which has a slightly weird license, but it might be possible for you to use it. But then you have to live with the fact that this has been paid for by horrible deeds done by Meta. So yeah, this is a problem. I don't think training will ever become a possibility for normal people or academics, for not otherwise funded entities. If that rules it out completely for you, then that is a stance as well that needs to be discussed. But yeah, this is a deep problem at the root of it. Yeah.
So I think the provenance of the training data is for our community a topic that we think about a lot. Obviously, because again, licensing is a very important topic for us in free software. You could say that creative use of the copyright system is one of the cornerstones of how we got going. And therefore, we feel that, and from our hearts, I think that if you don't display integrity about protecting the rights of authors, then you're doing it wrong as a free software person, since we rely on that mechanism so much ourselves. At the same time, obviously, a lot of us feel that we very intentionally release our code as open source because we want others to have access to it. So to some extent, we also care about there being a public domain. Our licensing doesn't correspond to the public domain, but we're adjacent to it. So given all of that, I think what a lot of people in the free software community are looking for is there anywhere credible activity to produce a clean training data set with known provenance of the data that you can sort of use guilt-free? Presumably as an academic, that's also something that you would have massive interest in. Are you aware of any sort of solid effort to curate a sufficiently large training data set that produces a model that would not give us sort of doubt and worries?
Yeah, as I said, this LLM initiative, this Olmo initiative, as far as I'm aware, they are documenting where the data is from, and that trying to make sure that at least under generous interpretations of the anyway, it's still contested what copyright law says about training. But anyways, so they are at least transparent about the data. But this is only one part, right? I mean, having the data is great, and you have several terabytes of data. That's great. But then training a model on it that requires several $1 million in compute is the next step, right? So that might be a barrier as well. But starting from the data, people are trying to address this.
Yeah, but
yes,
I think we're more fine with someone sort of donating the compute to us.
okay.
But if the
Or to
provenance
me.
of the data is I think, bad, that gives us more pause.
Okay. fair enough.
Maybe to answer your question or to do something with your question a little bit more. So you mentioned that you need a certain minimum amount of data to produce a model that is useful. But as a sort of non-expert, looking into the various releases that come out, there certainly seem to be a lot of people who are trying to build smaller models that maybe show much poorer performance in sort of knowledge queries, but still have better reasoning performance than you would expect from scaling the data down. And when it comes to integrating a model into our software that can sort of act as a function, usefully select among things that it's sort of zero-shot given as a prompt, maybe sort of a small enough model would actually be good enough for us, because we're not looking for that text box chat interface, or we don't aim to be a Wikipedia replacement, right? So how true is that notion that you as a model designer get to pick and choose a bit, as in, yes, your training data set is smaller, but the model architecture still makes it useful as a function approximator?
Yeah, you have to be careful there. There are two different dimensions to it that are somewhat orthogonal or somewhat independent of each other. One is the size of the model in terms of parameters, and you can get smaller models that are quite okay, that have capabilities, but they still need a lot of data.
Yeah.
And it turns out that overtraining, the training with a lot more tokens than people initially thought would be needed, even on smaller models, creates better models. So it's these dimensions don't go. Their dimensions,
still want the data.
right? You still need a lot of data, even on a model with fewer parameters.
So I think we have 2 minutes according to the sign, but hopefully.
Okay. Hi, David. Thanks for
Yes.
for doing this. I would like to draw attention back to this slide, and I noticed that you talk about cultural sustainability, but you don't talk about environmental sustainability. Why is that? Is that sort of like, oh yeah, we're going to have these?
That's meant to be in cost externalization. That's meant to be in there. The environmental sustainability.
Right. Okay. Either way, you know that all this is wishful thinking, right? Nothing of this is happening, nor there's any sign that this is going to happen. Doesn't this give you a kind of a pause of?
Well, I mean, I didn't give you my negative vision for AI, which is kind of the inverse of this, right? Yeah, but we have to fight for it. I mean, what can we do? We can't just resign. We can identify areas where we would like to intervene.
What?
Yes, I'm here. That's my attempt at telling you to be aware of these issues. I talk to decision makers. I talk to politicians who have dollar signs, who have euro signs in their eyes when they talk about think about AI, and I tell them, okay, so here are areas where you can really do something.
Yeah. It's to their thing, because that is what's happening, but you are kind of enabling them, right?
Yeah. I don't know.
I mean, exactly. That's the thing. So I think.
progress at any cost.
So I think no. What I mean is that I think, for example, now here at KDE, right? I think the worst thing that we could do is ignore the topic, because it is fraught with problems, and through a combination of hard work over 30 years and historical happenstance. We're one of a half dozen ways to use a computer, right? There aren't that many ways to interact with a PC. We're one of them. So I think that means we get to think about what stance we take and how to do it according to our value system, and hopefully show people a better example. So I think your worries are very appropriate, right? We have a KDE Eco initiative. What does that mean in the AI context? And what does it mean to using AI and KDE software as a very good thing for us to think about?
And we will continue
I see the sign, I'm ignoring it on purpose.
We will continue this conversation in the hallway.
I'm sure we will.
Thank you so much, everyone. And thank you for joining us.